Welcome or welcome back to 3 Inquisitive Kids. This video is going to be all about basic calculations on probability, lesson 3 of our entire chapter. Again, here's our course outline. We are already halfway through of our chapter, and it's going to be about basic calculations on probability. Our learning goals for today is to understand the method of calculating the probability of random events and be able to solve various types of problems. Here it's supposed to be explore. A dice is tossed. How many possible outcomes are there? Does each outcome have the same probability of happening? And what is the probability for each outcome? Well, we know that since this dice has 6 faces, there's going to be 6 possible outcomes. And yes, each outcome does have the same probability of happening because our dice is uniform on all sides. It's not like one side is going to be slightly heavier to affect the probability. The probability for each outcome is 1/6. For example, the probability for 1 is 1/6. The probability for landing on a 2 is also 1/6, and so on. Now, a coin is tossed. How many possible outcomes are there? Is it equally likely to get heads and tails? What's the probability of getting heads? So there are 2 total outcomes, 1 heads and 1 tails, because a coin has 2 faces, and they are equally likely. The probability of getting heads is 1/2. So what do the previous examples share in common? What do flipping coins and tossing dice have in common? There are only a limited number of possible outcomes, so that's one thing, and all outcomes were equally likely to occur. So you can see that for the dice, it was equally likely for each face to show on top, and for the coin, it was equally likely for heads and tails to show. So when we have situations with these 2 conditions, the ratio of eligible outcomes to the total number of outcomes is the probability. Let's continue to see what this means. Discuss. There are 5 identical balls in a bag marked with 1, 2, 3, 4, 5 respectively. Draw out a ball at random. What are the possible outcomes? Is each outcome equally likely to happen? What are their probabilities of happening? So the possible outcomes would be 1, 2, 3, 4, and 5. And each outcome is equally likely to happen because they are 5 identical balls. Their probabilities of happening is 1/5. There's a total of 5 outcomes to choose from, and if you just pick one, it's one of those 5. So, conclusion. Generally, if an experiment has n equally possible outcomes in total, and event A, so probability of A, is one of the outcomes, then we can express the probability of event A as m/n. M is technically representing event A, and n is the total number of outcomes. Here's some practice. What is the probability of rolling a number greater than 4? What is the probability of rolling an even number? So there are 6 possible outcomes after tossing a dice. Because the dice is uniform on all 6 sides, each outcome is equally likely to happen. There are only 4 outcomes greater than 4, which is 5 and 6. So the probability of getting a number greater than 4 would be, first, the denominator is the total number of outcomes, 6 outcomes. And we have 2 outcomes that follow the rule of being greater than 4. 2/6. It's 1/3. And there are 3 even outcomes in total. We have 2, 4, and 6. Those are all the even numbers. So if we have P, the probability of rolling an even number, it would be a total of 6 outcomes on the bottom, and 1, 2, 3 eligible outcomes, the outcomes that follow these conditions. So we can simplify it to 1/2. The key is to find first the total number of outcomes, that's for the denominator, and for the numerator, it's the number of eligible cases. So you have to find the number of outcomes that followed the rules given, so even numbers or numbers greater than 4. Find the probability of the following events. Number 1, landing on 2. Number 2, landing on an odd number. And number 3, land on a number greater than 2 but less than 5. So if we're going to land on 2, the probability is 1/6. because landing on 2 is one of the numbers out of the 6 possible outcomes. The probability of landing on an odd number is 1/2, and the probability of landing on a number between 2 and 5 is 1/3. Class summary. Generally, if an experiment has n equally possible outcomes in total, and event A is one of the outcomes, then the probability of event A occurring is m/n. I hope you learned something from this video, and be sure to come back for our next quick lesson on probability.